Welcome to the deep dive. Today we're jumping straight into Splunk fundamentals. We've got some really interesting source material here, practice questions, and importantly, their explanations from the SPLK-1004 exam. So our goal is to pull out the key knowledge nuggets from these questions for you. We're talking core concepts, search commands, knowledge objects, dashboard stuff, all the essentials.
Exactly. And using exam questions is actually a great way to look at this stuff. They force you to focus on the core function, the why, behind each feature in Splunk. We'll break down what they do and why they matter day to day.
Okay, sounds good. Let's dive right in then. First up, a basic search command the sources mention. dedup. What's its main job?
Right, dedup. It's essentially for removing duplicates. It looks at events, and if they have the same value in a field you specify, it removes the duplicates.
Okay, removes duplicates, but there's a specific way it does it, right? That doesn't just delete all of them.
Correct, yeah, that's key. It keeps the first one it finds, only the first occurrence.
Gotcha. So the first time it sees, say, user Bob, it keeps that event.
And then if it sees user Bob again later in the results, it drops those subsequent ones. So the practical use, well, like the source implies, if you need a unique list, maybe unique users or unique IP addresses that did something dedup, gives you that clean list without the noise of repeats.
Makes perfect sense. Okay, so from cleaning data with commands, let's shift to organizing it. The sources bring up a knowledge object for standardizing field names, especially thinking about CIM compatibility. Which object is that?
That would be the field alias.
Field alias. And it does
Yeah.
pretty much what the name suggests.
Yeah.
Lets you rename fields.
Essentially, yes. Or map different names to one standard name. Think about it. You get data from different places, right? One log might call an IP client tip, another calls it source address.
Yeah, it happens all the time.
So a field alias lets you say, okay, whenever you see client tip or source address, just treat it as SIRSIP.
Yeah.
And the big why here, as the source points out, is CIM, the Common Information Model. It helps you get your data speaking that common language so standard Splunk apps and reports understand it.
Right, normalizing the data for consistency. Very important. Okay, let's jump back to search commands for a sec. The table command comes up in the source material regarding its classification. Is it like filtering, reporting?
It's classified as a transforming command.
Transforming. Okay.
Yeah.
And function-wise, it creates a table.
Pretty much. It takes your search results and formats them into a neat table, showing only the fields you list as columns.
So it really changes the shape of the data coming out, not just filtering events, but restructuring the output.
Exactly. That's the core idea of transforming commands. They alter the structure of the results, often for display or further processing.
Clear. Okay, another concept the sources mention is a workflow action. What does that let a user do?
Workflow actions are about interacting from your search results. They let you basically launch external actions based on the data you're seeing right there in Splunk.
External actions, like outside of Splunk itself.
Yeah, exactly. The source gives examples like opening a URL or maybe triggering a script. So you could click on an IP address in your results, and a workflow action could automatically open your threat intel tools page for that IP.
Oh, okay. That's pretty powerful. It connects Splunk insights to actual actions or other tools.
It bridges that gap.
Cool. All right, let's talk about performance and data storage. The collect command. What's its main purpose according to the source?
The collect command's job is to send search results into a summary index.
A summary index. And why would you do that? What's the benefit?
Speed, mainly. Think about it. Instead of running a potentially complex, slow search over massive amounts of raw data every time you need a report, you run it once, collect the results into a smaller, optimized summary index, and then your reports query that summary index.
So you're saving the process results.
Exactly. Querying the summary is much, much faster. It's a key technique for speeding up dashboards and reports, especially those using large data sets.
Got it. Faster reporting through pre-calculation, basically.
Yeah.
Now back to knowledge objects event types. The source asks about the best scenario for using them. When do they shine?
Event types are really designed for grouping similar events
Grouping them how?
by giving them a shared name, like a tag.
Okay, tagging similar events. Why is that useful?
Well, you might have logs from different systems that all indicate, say, a failed login. The raw messages might look different. An event type lets you create a definition, maybe based on keywords or field values, and call it failed login. Then you tag all those different looking events with that one name.
So searching for event type failed login finds all of them, regardless of the original source.
Precisely. It simplifies searching and reporting by creating a kind of logical layer over your diverse raw data. It helps standardize how you categorize events.
That sounds incredibly useful for making sense of varied data. Okay, let's step into dashboards. The sources talk about an element that lets a user pick a value which then affects multiple panels. What element are we talking about?
That's an input dropdown, a very common dashboard element.
Right, the drop-down list. How does it control the other panels?
It works using tokens. When you select something from the dropdown, say a host name, that value gets passed as a
A
token.
token, like a variable.
Yeah, exactly. The searches powering the other panels on the dashboard can then use that token. So if the token selected host gets the value server 1, all the panels using that token in their search will automatically filter for host server 1.
Ah, so one selection updates multiple charts or tables simultaneously, makes dashboards interactive.
Definitely. It lets users easily slice and dice the data across the whole dashboard view.
Very neat. Okay, another command, bin. The source asks about its purpose. What's the bin command for?
Bin is used for normalizing values, specifically time or numeric values.
Normalizing. How does it do that?
It groups them into buckets or bins of a fixed size.
Buckets. Can you give an example?
Yeah. Sure. For time, instead of having events with millisecond precision, you could use bin time span 1 hour. That groups all events into 1-hour chunks. Or for a numeric field like latency, you might use bin latency bins 10 to group the values into 10 ranges.
So it helps you see trends over periods or ranges instead of focusing on tiny individual values.
Exactly. It's great for preparing data for charts or statistical analysis where you need grouped data, not raw continuous values. It smooths things out, like you said.
Got it. Okay, almost there. Data models. The sources mention accelerating them. What does enabling acceleration actually do?
When you accelerate a data model, you're telling Splunk to pre-compute summaries based on that model's definition.
Pre-compute summaries. Similar idea to summary indexing with collect.
Sort of, yeah. It's about pre-calculating things, but
So-
specifically for data models.
And the benefit. Speed again.
Absolutely. The main benefit, highlighted by the source, is making searches that use that data model much faster. This particularly affects things like pivot reports or dashboards built on top of that data model. Because the summaries are already built, Splunk doesn't have to process all the raw data every time.
So faster pivots, faster reports, if they're based on that accelerated model.
Right. It's a trade-off, uses more disk space for the summaries, but gives you potentially huge performance gains for those specific searches.
Makes sense for frequently used models.
Mm.
Okay, last topic, also dashboard related. Using a base search with post-process searches. What's the advantage there?
The big win, according to the source, is reducing duplicate search work, efficiency.
How does that work? You run one search first.
Yeah, that's the idea. You have a single base search that runs once and grabs a broad set of data needed by multiple panels. Then, each individual panel runs a much faster post-process search that only operates on the results already returned by that base search.
Oh, so instead of panel A running a big search, panel B running a similar big search, and panel C running another similar big search.
You run the common part once with the base search, and the panels just do their specific filtering or calculations on that shared result set. It's a really common and effective technique for making dashboards load faster, especially complex ones where multiple panels rely on the same initial data pool.
Right, do the heavy lifting once. Makes a lot of sense.
Considering the specific job each of these tools does, cleaning with dedup or bin, organizing with aliases or event types, presenting efficiently with data models and dashboard techniques, how does really mastering these individual pieces impact the whole process? How much faster, how much clearer can you make that journey from raw data to actual actionable insight within Splunk by deliberately choosing and using the right tool for each step?